Hi everyone, welcome to my tutorial on the Chapter 13 worksheet. So I will be teaching you how to write electron configurations and how to also write or draw the orbital notation. And I want you to get out your color-coded periodic table. It should look something like this, and I'm going to kind of explain it to you. All right, so you can see right here are the periods, and the periods are the rows. Okay, so see how they're numbered? So row 1 is the first energy level. Row 2 is the second energy level. Row 3 is the third energy level, so on and so on. So the rows or the periods will tell you what the energy level is. So that's why the number that's written in front of the letter represents the energy level. Then you will notice here in this section that's pink, notice that these are where all the S's are going to be. Okay? The only exception, of course, is the first row because there are only 2 elements in the first row. So you have to remember that in the first row, one of the S's for helium is over there. All right? So the S's are the first 2 groups, okay? That's where you're going to start filling the s orbitals. So let's think about this. How many different orientations for an s orbital are there? Only one, right? There's only one orientation for an s. So if there's only one type of s orbital, how many electrons can you fit into each one? 2. Remember, maximum of 2 electrons into each orbital. So look, count the boxes. 1, 2. Okay? Now, if you look on the right-hand side, this section here are where all of the P's are being filled, okay? This is what we call the main block group, okay? So the P's are filled in this section. And how many different P orbitals are there? There are 3 different P orbitals. Remember, one along the X, the Y, and the Z. And then how many electrons can you fit into each one? 2, right? So that means 2 times 3, which is 6. That's a total of 6 electrons in the p orbitals. So you'll notice here, 1, 2, 3, 4, 5, 6. Okay? Then if we take a look at the middle section, these are where your transition metals are. Okay? So the transition metals, in that area, when you come across that area or that section, you're going to start filling the D's, okay, the d orbitals. Now, something that you need to pay attention to, notice that this is the 4th energy level, the 4th row. So we hit the 4 S's, but notice what happens when we come across the transition metals. It goes back 1 energy level. Okay, it's 1 energy level behind. So this is something that you just have to remember. All right, the D's are 1 energy level behind. Then once you're done with the D's, then it goes back to 4. Okay, and then that's similar to row 6 and row 7. Row 6 and row 7, you're going to come across here, and then notice then these 2 come down here at the bottom. These 2 rows are really should be inserted in this section, but to make the periodic table look symmetrical, we throw them down at the bottom of the periodic table so that it looks a lot nicer, okay? So basically, if you're going from starting with energy level 6 here, you go here, and then you're going to come down here, and then when you're done, then you go back, okay? So you'll notice that this is row 6, energy level 6, and then the F's are going to be 2 energy levels behind. Okay, so the D's are 1 energy level behind and the F's are 2 energy levels behind. All right, so let's go back and talk about our d orbitals. So how many different orientations for a d? There are 5 different orientations for a d orbital. And then once again, how many electrons can you fit into each orbital? 2, so that's a total of 10 electrons. So count the boxes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then your F's that are down here, how many different orientations for an F? There are 7 different orientations for an F. So how many electrons would that be? That would be 14, right? So count the boxes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So that is how our periodic table is organized. S's over here, P's, D's, F's. Okay? And so your color-coded periodic table is just a learning tool. Once you get the hang of this, you're not going to need this periodic table. Okay? So you don't get to use your color-coded and labeled periodic table on the test, but I do provide you a periodic table, but it's just not going to be labeled and color-coded like this. It's just the regular periodic table that you normally get on tests. All right? Okay, so now that we kind of understand how it is organized, now I'm going to teach you how to write electron configurations. Okay, so you need to get out the chapter 13 worksheet. You can keep out this periodic table if you like, or you can get out your regular periodic table. This is what the chapter 13 worksheet looks like. So I am going to teach you how to do the electron configurations and the orbital notation. So let's start with the electron configurations first, and then the orbital notation, I can teach you that after we're done mastering the electron configurations, okay? All of these that are listed here, we're starting at the very beginning. So when it says like -1, it's just telling you number 1 on the periodic table, number 2 on the periodic table, so on and so on. So we're going to go and order the periodic table. So we'll do a few of them together, and then once you get the hang of it, then I'll let you finish the worksheet at your own pace. Okay, let's begin with hydrogen here, which is number 1 in your periodic table. So I'm going to flip to a periodic table so we can see what it looks like. Okay, so here's hydrogen right here. Hydrogen is probably the easiest one to do. So the first thing we always designate the energy level. So hydrogen is in the first energy level, so I'm going to put a 1. And is this the S, the P, the D, or the F section? It's the S section, right? So this will be labeled as 1S. And then we're going to use a superscript. The superscript will tell you the number of electrons, okay? So since this is the very first box, on the periodic table, it will contain only 1 electron, okay? So this will be written as 1s and then a superscript 1, okay? 1s1. So what this is saying, it's saying for hydrogen in the first energy level, in the s orbital, so that means that this cloud is a spherical shape, you are going to find 1 electron. All right, so you can see that the electron configuration is telling us the location of the electrons in the structure of the atom. Let's continue with the next one here, and the next one is helium, right? Helium is number 2. And when you're doing these electron configurations, first of all, you read the periodic table like you read a book, right? You read a book from left to right, top to bottom. This is how we're going to read the periodic table to determine how to write our electron configurations. Okay, so let's continue on. Helium is number 2. All right, so for helium here, what you're going to do is you always have to start from the very beginning, okay? So no matter what, whether we're doing an element way down here, we always got to start from the very top, the very beginning, okay? All right, so helium, start from the very beginning. So we're going to write the electron configuration all the way until we come across and our finger hits helium, okay? So you can just move your finger across the periodic table until you hit the designated element. So start from the very beginning. So we're in the first row, first energy level. So we start off with the 1. And this is the S section. And we're still in the S section in the first energy level because there's only 2 elements. So this is an S, and this is also an S. So we're going to combine the number of S's together for that particular energy level. So then it is 1S, and then we're going to count the boxes for the number of S's. 1, 2, until we get to helium. So this will be labeled as 1s2. Okay, now let's try the next one, lithium. So once again, start from the very beginning. So we're at the first energy level in the S section. So this would be 1s, and then count the boxes. 1, 2 for the S's. So it'd be 1s2. All right, we are going to keep going until we hit lithium. So we keep moving our finger across the periodic table. Now we're in the second row, second energy level. We are still in the S section, and it is the first box. So then this is 2s1. All right, so the electron configuration for lithium is 1s2, 2s1. And let me explain again what this is telling us. It's telling us for lithium in the first energy level, in the S cloud that is spherical in shape, we can find 2 electrons. Then in the second energy level, also in a spherical cloud, we're going to find 1 electron. So if you add up the total of the superscripts, there's a 2 there and a 1 here, that adds up to 3. And you see lithium is number 3. Okay? So the electron configuration, once again, is telling us the location of these electrons. All right, I want you to try and do number 7, nitrogen, by yourself, and then see if you can do it right. So pause the video, and then when you're done, then play the video to check your answer. All right, so nitrogen, start from the very beginning, right? Always start from the top. First energy level, S section, so 1s, 1, count the boxes, 2. So 1s2. And we keep going until we hit nitrogen. Now we are in the second row. This is the S section, right? So 2s, count the boxes, 1, 2. So 2s2. All right, we got to keep moving our finger across. Keep going until we hit nitrogen. Now over here, we're still in the second row, but now we are in the P section. So 2p, and we're going to count the boxes until we hit nitrogen. So 2p, 1, 2, 3. 2p3. Okay, so that is the electron configuration for nitrogen. 1s2, 2s2, 2p3. Okay, now you can see that since we always have to start from the very beginning, then these electron configurations are going to get very long. Okay, they're going to get very long because we just keep adding on to them. There is a shortcut. So now I'm going to show you how to do the shortcut method. You have to know how to do both. You have to know how to do the complete configuration, and you also have to know how to do shortcut. Okay, now let's do a transition metal. All right, titanium. Okay, titanium. So before we do this one in the shortcut version, let's go ahead and practice our long or complete configuration, doing the long way. Okay, so I want you to do the long configuration for titanium, and then we'll condense that into the shorthand way. All right, so let's see. Titanium, start from the very beginning. So 1s2, right? First energy level, S section. So 1s, count the boxes. 1, 2. So 1s2. Keep going. Second row, S section, 2s2. Keep moving across. Now we're in the P section, still the second row. 2p, count the boxes. 4, 5, 6. 2p6. Keep going until we hit titanium. Third row, S section, so 3s2. All right, keep going. 3p, count the boxes. 4, 5, 6. 3p6. Keep going. Now we're in the fourth row, 4s2. Now we're finally in the transition metal section. Don't forget, in the transition metal section, it's one energy level behind. So this goes back to 3. So this is 3D, and then count the boxes until we hit titanium. So 3D2. Okay, so that is the electron configuration for titanium. Now you can write your electron configuration in the order that you see it on the periodic table. So it is okay to have a 3D written after the 4s. Some people like to put all their numbers in order. So if you want to move this 3D in front of the 4s, that's fine too. Both ways are correct. Now you can see that it's very long. Now I'm going to teach you how to write this in shorthand. So the rules are, you go back to the previous noble gas. So this is going to be titanium in shorthand. Go back to the previous noble gas, and you're going to put the noble gas in brackets. So if titanium is here, go back to the previous noble gas, which would be argon. So I'm going to put argon in brackets. Okay, so argon in brackets. So once again, previous noble gas in brackets. What this is saying, when we write it in brackets like this, it's saying that the electron configuration all the way through argon. Then, once you put the previous noble gas in brackets, all you do is write what comes after that. Okay, so it'd be argon in brackets, and then it'll be 4s2. And then go back to 3D, right? And then 3D2. So basically, this whole section here, that's all argon. So that's why you would just place argon in brackets, and then you write what's left, 4s2, 3d2. And that's the shorthand way. So on your Chapter 13 worksheet, you can put a star next to potassium, and that's when I will let you start doing shorthand on the worksheet. Okay, is when you come across potassium, you can do shorthand for the rest of it. All right, so that's how you do electron configuration. Now what we're going to do is we are going to do orbital notation. Now let's go over orbital notation. So now we're going to do the orbital notation. You see all these lines here. Notice that for an S, there's only one line drawn, right? Here's an S and only one line drawn. And that's because there's only one orientation for an S, or there's only one type of S orbital. So each line represents an orbital. And then here are your P's. So how many P orbitals are there? 3. So that's why you see 3 lines. Okay, so 3 lines for a P. And then there are 5 lines for a D because there are 5 different D orbitals. All right, so when we write the orbital notation, we are going to use arrows to represent the electrons. Okay, we are using arrows to represent the electrons. And we typically start with an up arrow. And there are only, you can have 2 electrons in each orbital. Okay, remember that is the maximum number of electrons in an orbital. And these electrons have to have opposite spin. And that's to reduce the repulsion in the atom, to make it more stable. So then we represent the electrons with either an up arrow or a down arrow. So that will indicate that they have opposite spin. All right, so let's start with the hydrogen. So the hydrogen we have already designated as 1s1. So in the 1s, we're going to put 1 arrow in the 1s orbital here. So I'm just going to write 1 arrow. Okay, that's kind of bad. Let me try that again. Okay, so just draw 1 arrow. Now I draw my arrows like that. Sorry, that looks bad too. Okay, I draw my arrows like this. That means that I just draw it with, that's called a hat. So I draw it with a half hat. If you want to put a full hat on your arrow, that is perfectly fine. It doesn't matter. You'll realize that drawing so many arrows, just writing a half hat is a lot faster. So that's 1s1. Then let's go to the next one. Helium is 1s2. So when we write the orbital notation for 1s2, one up arrow and then one down arrow, because they have to have opposite spin, and you can only fit 2 electrons or 2 arrows on each line. Then let's go to the next one. Lithium, 1s2 and then 2s1. Okay, so that means 2 electrons in the 1s and then 1 electron in the 2s. Now let's go to nitrogen. So 1s2, so 1 up, 1 down, 2s2, 1 up, 1 down, and then 2p3. So watch how I write the orbital notation for nitrogen. There's a rule here. So I'm going to go 1, 2, 3. Notice that I put an arrow on each line first, okay? You are not going to write it like, let me just sketch this out over here. So if those are the lines for the P, nitrogen would not look like this, 2p3 as this. Okay, so that is incorrect. You're not going to write it like that. So notice once again that they are not paired yet. Okay, the rule is there has to be at least, for the particular sublevel, there has to be 1 electron on each line first before it can be paired with the opposite spin. Okay, so if it was 2p1, you would just have 1 arrow. If it was 2p2, it'd be 1 here and 1 there. And then 2p3 looks like this. So if we go down now and do the oxygen orbital notation, it is 1s2, 2s2, 2p4. So 1, 2, 3. Now you're going to go and pair it with the opposite spin. So that's already 3, so now we go and pair this one, and that's 4. Okay? And then you just keep going from there. All right? So go ahead and continue working on this, and I will walk around and help people if you have any questions, or if you have any questions, make sure you ask. All right, good night.